Hi guys, today we are going to see trigonometric ratios of complementary angles. Okay, firstly, what are complementary angles? When the sum of two angles is equal to 90 degree, then both the angles are said to be complementary to each other. Okay, now what are we going to do with this? Oh, let's see that. Sin 90 degree minus A can be written as cos A. Okay, which means that cos A can be in turn written as sin 90 minus A. Similarly, tan 90 minus A can be written as cot A. Secant 90 minus A can be written as cosecant A. Cos 90 minus A can be written as sin A. Cot 90 minus A can be written as tan A. Cosecant 90 minus A can also be written as secant A. Based on these formulas, we are going to do exercise 8.3. Let's start exercise 8.3. Now I am going to do the first sum, first subdivision. Sin 18 degrees divided by cos 72 degree. Now we have to evaluate this. In this, you see it is written as sin 18 degrees in the numerator. So based on the formula we learnt before, we can write sin A as cos 90 minus A. So this sin 18 degrees can be written as cos 90 minus 18 divided by cos 72. Okay, now 90 minus 18 is 72. So this can be written as cos 72 divided by cos 72. Since both numerator and denominator are equal, we can cancel both of this and the answer is 1. Sorry, 90 degrees, it must be mentioned as 90 degrees, 18 degrees, 72 degrees. So cos 90 degree minus 18 degree gives cos 72 degree. So cos 72 degree and cos 72 degree gets cancelled and we get the answer as 1. Evaluate cosecant 31 degrees minus secant 59 degree. Here we know that cosecant A can be written as secant 90 degree minus A. So instead of cosecant 31 degrees, we can write it as secant 90 degrees minus 31 degrees minus secant 59 degree, which is already in the question. Now 90 degree minus 31 degree is secant 59 degree, and already here minus secant 59 degree is there. So secant 59 degree minus secant 59 degree is 0. Now let's move on to second question, first one. We have to prove that tan 48 degree, tan 23 degree multiplied by tan 42 degree multiplied by tan 67 degree is 1. So let us take the LHS. In the LHS, it is given as tan 48 degree multiplied with tan 23 degrees multiplied with tan 42 degrees multiplied with tan 67 degree. So we have to change certain things and prove that the answer becomes 1. Okay, I have written the LHS here. Now we are going to change certain signs. Let us write tan 48 as it is, tan 23 degree as it is. Now we know that tan theta can be written as 1 by cot theta. So tan 42 degree can be written as 1 by cot 42 degree. Similarly, tan 67 degree can be written as 1 by cot 67 degrees. Okay, next we know that cot theta can be written as, which means cot A can be written as tan 90 degrees minus A. So we are going to substitute this here. So we get that tan 48 degrees multiplied with tan 23 degrees multiplied by 1 by, instead of cot 42, I am going to write it as tan 90 minus 42 degrees. 90 degrees minus 42 degree multiplied by 1 by tan 90 degrees minus 67 degrees. Okay. Here it is tan 48 degrees. Here it is tan 23 degrees. And here 1 by 90 minus 42 is 48. So it can be written as tan 48 degrees. Multiplied by 90 minus 67 is 23. So it can be written as tan 23 degrees. So tan 48 get cancelled. Tan 23 get cancelled, and the answer is 1. Hence proved. Okay, now let's move on to the second subdivision. The question is cos 38 degree multiplied by cos 52 degree minus sin 38 degree multiplied by sin 52 degree must be equal to 0. Here we are going to take the LHS. Cos 38 degrees cos 52 degrees minus sin 38 degrees sin 52 degrees. Now let's keep the cos as it is, and we know that sin can be written as cos 90 minus a. So here I can write it as cos 90 minus 38, and this also I can write it as cos 90 minus 52. I mean 90 degree minus 38 degree, 90 degree minus 52 degree. Okay, now this can be written as cos 38 degree cos 52 degrees minus, so 90 minus 38 is 52, so cos 52 degrees. Here it can be written as cos 90 minus 52 degree is cos 38 degrees. See, both are same. So when we subtract the same values, it becomes to be 0. Here we can also change, instead of changing this sign to cos, we can also do it by changing this cos to sin and cancel both of them, and it can become to 0. Both the ways can be done. Now let's move on to fourth question. If tan A is equal to cot B, prove that A plus B is equal to 90 degree. So let's write the given one. It is given tan A is equal to cot B. Here we know that cot B can be written as tan 90 degree minus B. So instead of cot B, I am going to substitute it there. So tan A will be equal to tan 90 degrees minus B. Here since both are tan, I can equate the angles. So A will be equal to 90 degrees minus B. When I take this minus B to that side, it becomes A plus B, which is equal to 90 degrees. Hence proved. Now let's move on to fifth question. If secant 4A is equal to cosecant A minus 20 degrees, where 4A is an acute angle, find the value of A. Now we have to find the value of A. It is given that secant 4A is equal to cosecant A minus 20 degrees. Okay, we know that secant A can be written as cosecant 90 minus A, 90 degree minus A. So instead of secant 4A, I can write it as cosecant 90 degrees minus 4A is equal to cosecant A minus 20 degrees. Since both are cosecant, I can equate the angles. So 90 degree minus 4A is equal to A minus 20 degrees. Okay, here 90 degree I keep as it is, and minus 20 degree when it comes to this side it becomes plus 20 degree, and A I keep it as it is, and this minus 4A when comes to that side becomes plus 4A. Now 90 plus 20 is 110 degrees, which is equal to A plus 4A is 5A. So when this 5 comes to this side, it goes to the denominator. So when I cancel according to 5 tables, A becomes 22 degrees. That's all. Okay, let's move on to question 6. If A, B and C are interior angles of a triangle ABC, then show that sine B plus C by 2 is equal to cos A by 2. Okay, it is given that A, B, C are interior angles of a triangle. If a triangle is there, angle A, angle B, angle C, these are the interior angles of a triangle. We know that sum of the interior angles of a triangle, that is A plus B plus C, is equal to 180 degrees. Okay, now we are going to divide both the sides by 2. We get A plus B plus C by 2 is equal to 180 degrees by 2. So we can cancel both this and we get as 90 degrees. Here I can write it as A by 2 plus B plus C by 2 equal to 90 degrees. I can bring this A by 2 to that side, so it becomes as B plus C by 2 is equal to 90 degrees minus A by 2. When I take sine for both the sides, it becomes sine B plus C by 2 is equal to sine 90 minus A by 2. We know that sine 90 degree minus A can be written as cos A. So instead of this, I can write it as sine B plus C by 2 is equal to cos. So instead of this, I can use this formula and write it as cos A by 2. That's all. The formulas for these is available in our Telegram channel. To visit our Telegram channel, the link is given in the description. So you can go and download it in both PDF and JPEG format. Thank you.